So these are 6 formulas. The idea is, and this is kind of the maximum math stuff we do in here, is I basically want you guys to be able to understand pH, right? That's really what we're after. So hopefully you understood, and it's kind of hard to explain, but basically I hope you're getting this idea that in every water system, so I'm looking around the room and I'm like, this is kind of a water system. Your Coca-Cola, right? That's a little bit of a water system. Some of you have is this pure water? None of my business, whatever. But anyway, right? That's all that water has a certain pH. And if it's pure water, it's probably slightly above, it's 7, very close. That stuff's probably a little acidic, right? So it's where on the pH scale? Less than 7, right? So a little under, and then this stuff might even be a little basic. I'm guessing, I don't know. So it's a little high, but coffee might be acidic, I don't know. But the milk stuff might be a little above. But then with it, right, we can measure either the H+, and that then gives rise to the pH, and that's what this is all about. Like if I knew the H+, does everybody understand this? This is talking about a molarity concentration. It's how many moles of H+ are swimming around in there per liter of water. So that's perfect. That's literally how much H+ is floating around in that liter right there. That's what we're talking about. Is that okay? The pH literally focuses on the e to the minus. So if I said, oh, there's not very much, can everybody see that? It's a little dim. Okay, whatever. Can you see that? Which we go, okay, scientific notation goes 1 times 10 to the minus 1, 2, 3, 4, 5. Right? Who knows if I took the negative log of this, what number would pop out of there? 5. So if I take the negative log of this, it would come out 5, so we would say the pH equals 5. And the idea is that the pH focuses on that power. Is everybody okay with that? So that maybe you never understood that about pH. It's just, we call that orders of magnitude, right? It's the deal, like think about your money. It's like $1 versus $10 versus 100 versus 1,000. Those are orders of magnitude. Not $1, $2, $3, $4, $5. It's a 0 every time. Yes? Okay, that's what we're talking about. So, in the pH world, we focus on that because it really matters, like to biochemistry, to biological applications, whether it's changing by 10 times. But if it just changes, like I went from 1 times 10 to the minus 5th to 2 times 10 to the minus 5th, it would not really impact anything. Yeah, it means you add more H. Like she pours her Coke into her pure water, all of a sudden the H's are changing and they're getting more and more because it's getting more acidic. You with me? So to your mouth, like whether that means anything, like are we getting to where I'm going to have cavities? It's whether it changes by a pH unit, not just from 1 to 2. Does that make sense? So that's the whole point, why this scale ever got brought around. Otherwise, we just leave it like this. This is the facts. So we just focus on that. Everybody okay with that? But for every H+ there's in there, there's also OH minus. Right? And that's kind of the harder thing that a lot of people don't understand about water, is that water makes a little, it disassociates into a little H+ and there's a little OH minus. And so what I wanted to show you with Le Chatelier's was just say, look, if the H+ increases, it forces the OH down. If the OH minus increases, it forces the H+ down. They don't change at the same time. They don't both go up together. Is that okay? Yeah.
And the higher the pH is more acidic or basic?
Yeah. So the higher the pH is more basic.
Basic.
Yeah. So that's the problem with the negative on it. That all came from here. that's a problem, it made it work in opposites. So what we do is we start at 7, we say, that's what we just call pure water, it's neutral. And then when we get more and more H pluses in there, this starts happening. It starts going down. Right? And then if you get more basic, you start going like this. And that's on the pH scale. In another world, not really anything you guys probably would ever do, and I very seldom have done it. I've been a chemist a long time. But we did work on what was called the hydroxide exchange membrane. So all we cared about was hydroxide. We didn't really want to track the H+, we wanted to track the hydroxide. Guess what? There's a pOH scale. Just exactly the opposite. All I care about is what is the OH minus concentration. If I wanted to find the pOH, I'd take the negative log of it. Then I'd have to think in opposites, and I'd go, okay, so just so we say, more H+, which by the way means less OH minus, right? But if I go over to the other one and I go, oh, I'm going to watch the pOH scale, we're throwing that in for you guys for free. Thank you very much. You guys are like, shoot. But it's okay, it's simple. You just said it, it's just opposites. So if I start here, that means not very much OH minus. And then I can just start cranking down 10, 9, 8, 7. Still work, that's called what we call neutral. And what does neutral mean? It means OH minus is equal to H plus. They're both 10 to e to the minus 7. And then as you go down here, you go 6, 5, 4, 3, 2, 1. On this scale, if it's the pOH scale, that's more OH minus and less, anybody? 8 plus. Bingo. Okay, so here's the goal. This is it. This is all we're going to do on this section once we accomplish this today, and then we're moving on to gas. Okay, you ready? If I gave you one of these, I want you to find the other 3. That's our whole goal today. To start off. You with me? So if I say, hey, the concentration is 1.3 e to the minus 3. Okay? Now, the easy thing, just so you catch this, because it helps you check your work sometimes. Whenever I solve for this, it's somewhere between 3 and 2. Right? When I solve for this, it is 5. Correct? So anytime I have some other number out here, I know it's somewhere between 5 and 4. It's a quick check. Yeah, because it's not quite the 5, because if it was 1, it would be exactly 5. That's exactly 5. But as I start to get bigger than this, I'm on my way to becoming 4. So I know I'm somewhere between 5 and 4. Good? Thanks. You're asking really good questions, by the way. You should take her out to eat afterwards or something. That's a very good question. Good? You ready? Now watch. So we're going to literally walk our way. Well, I call this walking around the block. It's like if I know this, I can find the other 3. So I'm going to do it with my calculator. I'm going to do the top one through with you. You ready? So we'll all get our calculators. I'm going to show you some of the tricks on the calculators too. Because if you have a calculator, I'm going to look at one. I just randomly walk over to one that's odd to me. And I'll go, I just want to see what, yeah, so this is cool. I'm going to check something. I'm going to go 9 times 6 equals 54. Now I'm going to go, I'm going to clear that out. I'm going to go 1 times answer. So it remembered that, right? So I'm just going to keep that in mind. You guys have a key, especially if you have one of these. That is called an answer key, and what it means is whatever you said equals, it remembers that. So whenever I pull that up, I can actually use that answer I already had. So yeah, these don't look, oh, you do too. So look above your minus sign, you got a little blue A and S. So if you hit second answer or that, you can borrow that.
Cool.
So keep that in mind. We're going to do that together. You guys ready? We're all going to calculate this. Somebody tell me the formula. What am I going to do to this to get to the pH? Negative log. So here I go. I'm going to literally hit, and by the way, when you hit negative, here's another thing for calculators. This, I don't know why. There's a minus sign that means the subtraction function minus, and there's also a little minus in parentheses, which means the negative form. Just, mathematically it's the same thing, but I don't know. I don't know what they did there. Some computer guy's going to have to explain that to you. Anyway, when we do this, we mean the negative in the parentheses. Okay, so minus log, log, not ln, right? Now I'm going to use my scientific notation for me, 1.3 second e to the minus 3 in parentheses. And some of you have, instead of e to the, you got exponent, you got SCI, you got something, right? Equals, answer? 2.88? 2.9? And that's why we're all stopping. So something happened with this form. What am I?
Oh, wait, oh, right.
Do you know? Do you know? Did yours work? You guys talk, because...
Oh, wait, I got an error again. Negative log.
Okay, here we go. Good. You look like you're on the right track. I'm going to go negative. Then you go log, log, 1.3, e to minus 3, 1.3 second e, right? Yep. And then we got to hit the same minus 3 and then hit this one more time. Hit enter. Ah.
Did you get it?
I'm fine. As soon as I do negative log, it says error.
1.3.
Yeah, let's see. Yours is, that might be
I'm
one
gonna
because
print
there's...
times 10 to the negative 3. That's what I did.
I think, did you use in that?
Oh,
negative?
yeah.
Okay, so negative. And then we hit log here.
You click on this when you try to put the negative.
Yeah, that one. I see. Okay, let's do it this way. Do log
1.3.
And then you did it times 10.
You have to manually do
This, right?
1.3 e to the
And then you should get
Negative
3, and then that's where you
You just want like
put
big
minus,
exponent.
Oh, okay.
right?
Oh, I see. Oh, I see. Okay.
I think. I don't know.
I'll have my other one.
Yeah.
Borrow first.
Interesting. I have to think about that one. That's good.
Mine's doing the same.
Yeah.
Times 10 to the negative 3.
Yeah. Oh yeah, so you can do that, but be a little careful with that one. You gotta make sure you bracket that properly. Okay, we're getting close, but if you're on the phones right now, just plug in 2.9. Is that okay? Now, once we have that, what do we have to do to get to this? We got a couple options. Now, if I was here, I'm probably not gonna go here. I'm gonna go here. Because to get from here to here, I do what?
Mine is from 14.
Yeah, so I can take my answer from 14, so I'm going to go 14 minus second answer. Oh, 11.11, correct? See how I got to get that answer anyway, so I'll go a different way. That way I don't have to re-enter anything. Is everybody okay with that? Getting 11.11? Now once I know that, I can get to this, right? Because that formula is down here. It says, if I know this, I raise it to the power of base 10 and I'll actually get the OH minus. Correct? So here's what I'm going to do now. I've got that on my screen, 1111. Everybody with me there? I'm now just going to go this, and this would work on yours. You're basically going to go 10 raised to the, it looks like a caret. It looks like a little, I'm going to go 10, I'm going to go there. If you don't have it, you might have a, do you have a y to the x key?
It's like X and a little.
You have anything like that? Something like that?
Or it's a carry, you said?
Oh yeah, x to the block. So the caret. So I'm going to go 10 to the caret. And then I'm going to go parentheses, I'm gonna put my negative sign in, and then I'm gonna go second answer. And in the parentheses, and 7.690 to the minus 12.
What if we got 7.76?
7.76 e to the minus 12.
Yeah.
You're perfect.
Okay.
Small little variations like that won't matter because you're going to have a multiple choice test.
Okay.
And just so you sleep well at night, the rounding can be different with these. And we can't even get into the scientific, like how they round on exponents.
What was it?
I couldn't even tell you if I had to. I think it out every once in a while. Yeah, you got it. See it? 7.7 times 10 minus 12. Yes. Yeah. Okay. So now I'm gonna fill that out. We're gonna just do the rest of these, and then there's some people that need help with their calculators, and I'm just gonna walk around. And then also, if you look over, and you got it mastered, and you're like, oh, we use the same calculator. You help each other out. And let's get through this set and see if we can fill our way around the table. But again, if I know this, I could go here, or I could go here, whichever works. 14 minus this gives me that. 10 to the minus this gives me that. You know, you gotta walk around the block, and you can do it however you want. And if you want to re-enter something to get it, it's okay. It's not like a crime. I'm just trying to help you minimize error. Is that okay? Let's see if we can fill these out and get comfortable using our calculator so that if I gave you one, you could find the other three. That's the whole goal. And they all base on these formulas. Those formulas will always be given to you. And in your mind, because I don't want you to ever get removed from the concepts I'm trying to teach you, is just remember, if there's a certain H plus, there's a resulting OH minus. That's what Le Chatelier says. Together they always equal 1 times 10 to the minus 14. If you multiply them, if you're doing the negative logs, you can add them up to 14. They always work together. And away we go. All right, let's start working, start talking, start getting some help. See how we're doing. I have 2 calculators if you guys want to practice on those. I have this one and I have this other one. If you want to just run it through just to get the feel and see how it runs around the block, so when the time comes. How did yours work that now? Which one would you work on first? Oh, okay, based on the POH? Okay, so let's see. So what we're going to do is we're going to go 10 raised to the power of, let me see. Well, actually, it's right there. So we'll just go use that. So set the yellow key.
Yeah, I just trying to.
But it's negative.
And then we start the parentheses. Then we go, and then we have to oh, yeah.
That's the one I think I'm up. That's the one I messed up on. Okay, hold on. Wait, so if I have
Yeah, you take it for a spin, see if you can read it.
I can use this one, right? Negative 9.6.
Don't worry about it.
Oh, turns into the.
Oh, yeah, no,
I
this
just
is
didn't
for
see it.
scientific notation. It does.
I just didn't see the ending.
But,
Okay.
yeah, so this is for doing scientific notation, and then that's the key you want to use. Good. We found your key, Alice. It's actually sitting here in the gold. That's the 10 to yeah, there you go. Activate it with that shift.
Because even if you do the other one, it changes.
Yeah. Pretty good skill set. What I think you'll probably be doing most predominantly in your business would be this. If I know this, I got to know that. If I know that, I got to know that. I just, something you might be doing probably more in your training than you really do in your day-to-day. But at least you'll know how to get between pH and H+. Is that okay? You guys need a minute to finish? Okay. Let me know when you're done, so we can blow something up.
So another equation that you
Yeah,
can do
I know,
with
I was
this,
like,
que él no tiene, is
Right.
14 minus
I know it shifts, but I'm
the
like,
pH
So if I didn't
equals pH. Another equation he doesn't have there, but you can use it. So aquí si vamos a encontrar pH, que es este, ya tenemos the pH, right? So it's 14 minus that. So it's 14 minus 9.6, 4.4. Mira, ya está. 4.4. That's 4.4. Okay. So now we're going to try to go to OH minus. So ¿cuál de estas equations tiene OH minus? That equals to OH minus. This one.
Yep, that's it. Yep.
No.
What we call
He has them backwards.
not diatoms.
See, do he has?
Yeah,
O sea, it's not
still
something
yeah.
to something equals. He has the equal to the equation. Okay. So, okay, aquí ya vamos a usar esta, right? So tenemos 10 to the POH, which is this one. The POH is 4.4, so we're going to apply that one right here.
The other aspect of have
So we'll do the 10 bracket parenthesis to the negative 4.4 parenthesis.
No one ever says those are easy. They're easy the other way around. For you, that's easy. Okay, good. Yeah, I love that. Yep. Yeah, and for you guys, you only need to add carbonates, bicarbonates. Oh, yeah, yeah, so. And, yeah.
Ahorita Luis sí se salió y ahora no salió.
But carbonates and bicarbonates might be something that you do or whatever. Oh. That is actually
Dice parenthesis, right?
Weak base, right? Yeah.
5.4. Right?
Go back to the other one. Do this one it is.
So we call, but that's
So that one dijimos que era 10 bracket negative to
like how you push it, move to the right,
I don't
to
know
the
what
left.
is it. What is ran to
Eso
the
sí me
right?
sale.
Like what ran to the right?
Yeah,
What is
You
it?
want this?
yeah, good.
No me salió. Bracket to the negative. Mira, eso sí me salió. No voy a hacer la de abajo. 10 bracket. No.
So I'm just, here's a reaction, just a common reaction. Zinc, hydrochloric acid,
No me sale.
chloride,
Sí me
hydrogen
sale
gas.
con la otra.
Is that okay?
Sure.
Now, if I say ran to the right or ran to the left, what I mean is, the question came up about equilibrium and just this thing about Le Chatelier's products. Because these are the products that are on the right-hand side.
Oh,
That's what to the right means you're going towards products.
just literally on the right side of the equation.
Yes.
It's a lot more simpler than I was.
It is very simple, but a lot of times that phrase is thrown around, people don't understand what it means. If you're running a reaction to the left, it means the reaction doesn't run very good. It stays unreacted as reactants. So if this didn't run very good, like I put these together and I made very little hydrogen gas, yeah, like I just do this and this mostly just hangs out back here, then that would be called staying left or favoring reactants or even running backwards is the way people say it. Like this reaction prefers to go backwards instead of forwards. Is that okay? And Le Chatelier said if you stress a system by adding more of, so let's say I want to go backwards. Like I, for some reason, want to make zinc out of zinc chloride and H2. He says stress it by adding stuff here and it'll go backwards to remove that stuff.
Okay.
So if I literally had this reaction and it was sealed and I started pumping hydrogen gas into a sealed container, it would force it to go backwards.
Meaning it would
make more of this and consume this. It would go this way. And that's equilibrium. But on the other hand, if I want to make more of that, I could force it by adding more of this or removing any of this as it's made.
So how do we know on the right there's more products than there was before? Is because it's an H2, there's 2 H's now?
Oh, no, you wouldn't know. You'd have to have numbers. Like
Right.
you'd have, is there more than before? You'd have to see numbers. Like,
Right.
let's just say at equilibrium,
Uh-huh.
like it's done running, you walk up, pop open the reactor, and all these things are present, and I measure them and I go, 1 molar of this, 1 molar of that, and I made 12 molars of that, and 12 molars of that, then I would go, oh, this favors running to the right,
Okay.
correct?
Okay.
Now, let's say that I ran this. Do you make sense?
Oh, I wasn't really paying attention.
Oh, but imagine this, that you're, here, let me make it things you know, because you guys probably aren't running chemical reactions. Let's say that you decide to start the fire in your fireplace. And you put stuff in there, and you put the match to it, and you let it run for a while, and when you get done, some of that wood is unburned. But most of it burned up. You would say that runs to the right, but it is not all used up, because there's a little unburned wood, and in fact, if you kind of chip off the black, you could start it and make it run a little more to the right, correct? That's all Le Chatelier is saying. He's saying some reactions are really bad that way. And in fact, if you put wood in a fireplace and you don't chop it up at all, like you just leave a block of wood and then you just get a little piece of paper and you start it, you get a little black scorch on the wood and it's done, and you're like, I hardly reacted it at all. That meant it favored left.
So to reach equilibrium, does it mean that it's completed? This reaction is completed?
It's completed under the conditions at which you ran it.
Okay.
And the conditions are how much stuff you put in,
Uh-huh.
the temperature in the room, in that reaction I just gave you, how the surface area of the wood. Like if I'm a Boy Scout and I want to burn that stuff all up, I'll chip it real thin. I'll say, or a Girl Scout, sorry, right? I'm in the wrong room to say that comment. Right? You got very fine, high surface area stuff. I put a match to it, it almost burns to completion. I have now favored pushing that reaction to the right. Yeah, it's kind of wild. But this is here's where your mind will be blown. What if I took CO2 and water and I literally knew how to push it backwards into the starting gas again? Like we talked about in this class, that gasoline plus oxygen makes carbon dioxide and water. And all of a sudden you're sitting there in the war in your Germany. And this is a true story, in case you're wondering why I'm going down that dark road. And you're like, we're running out of fuel and we're going to probably lose the war. So they got a hold of their scientists and said, can we push that backwards? Can we take CO2 and water and make it back into gasoline to make more fuel? And this guy named Fisher, he said, yes, we can. And here's the chemistry behind it. You just push the reaction backwards. And CO2 plus water started making fuel again. Which, by the way, we're not, right? We would kind of like to still be doing that. Right? We'd like to take the greenhouse gas, CO2, that's killing us, and start pulling it back out of the air and turning it back to gasoline. And then if we started cycling it that way, we would
Have gas.
we'd have gas back and we'd get rid of the greenhouse gas. That'd be cool, huh?
And why can't we do that?
We do.
Okay.
But we're not very good at it yet, but because we didn't used to worry about it, but now we care about it. So yeah, I actually worked on a project which we took coal, wasn't the exact same, but the same problem. We took coal and turned it into jet fuel.
Cool.
Yeah, and that if you ever ran the 270 corridor over there, you know, you go by all those plants. Wow. Am I getting old or what? Oh, the company was called Rentec that I consulted on that project. And so if there was a tower there that said Rentec on it, that's literally what they were doing there. They were turning coal and turning it back into jet fuel. And there's all of that has to do with politics and money. So at the time, we thought we were gonna run out of oil reserves in this country, but we have lots of coal. So it was advantageous for us to take coal and turn it back into fuel. And then we wouldn't have to get all of our oil from the Middle East. It's a good idea. But then we figured out how to frack, and then we're like, now we have more oil than anybody else, and so now we don't care anymore. Which is like, it's too bad. Anyway, so it happened. By the way, that thing was stinky. There was like, the catalyst that made that, it stunk. Like I would drive by and I'd have flashbacks to working with that crap. I'd be like, I don't know why it smelled so bad. Anyway, side note. How are we doing? Good? Good question, by the way, because Le Chatelier's, now let's get to you guys, right? Because you're probably, maybe, I don't know, maybe somebody will get the bug, who knows? I'm going to be a chemistry major, I'm going to go Fisher Tropes, who knows? But if you go forward with what you're doing, what we're thinking about is like the enamel being the forward reaction, the forming of enamel, and the decomposition of enamel being the backwards reaction. So we want to disfavor that coming apart, and we want to favor it going forward. Does that help you see the context of this? Okay, that's why we're getting to this. All right, shall we do some gas? Cool. All right. Good question. No pressure, but you guys are like the best class I've ever had. Long time. Quite fun. You ask good questions. Kind of keep me on my toes. Speaking of,
Does that mean like something with pH of 5 has that concentration of
H plus, yes. Yep. And remember, the H plus is the acid.
If it's 5, it's always that.
Yep. Yep.
And then if it's like 4, it's just that's
1 e to the minus 4. Yep, that's exactly right. 10 times less concentrated, or more concentrated. Yep. All right, so